highlight them, put them up on the board when we have quizzes and stuff. And we don't have a quiz this week, right? As far as I know, it's not on my board. It's not on the board. I'm not going to give you one. So that's not fair. All right. So I'm on page 163. So they give you this particular problem. And remember, we said this is functional notation that it's written in. Not mine. All right. So hi, we gonna do math today, or we gonna do nothing and screw around, because you can go play in the dean's office if you want.
I hate going to my dean's office. He doesn't like me.
Okay.
What page is it?
163.
I appreciate that.
All right, so remember I said this is just a fancy name for saying why, right? Okay, so we have an understanding of that. Can you see over my head? Okay, cool. So the first question talks about, hey, determine C at 50 and interpret the result from the context of the problem. Okay, so they want us to do C at 50. So it says, use the cost function to answer questions. The function calculates the cost in dollars of producing X amount of candles. Okay, so we're candle makers now. So I'm going to take this 50, and I'm going to plug it into my above equation. So I get this. And that's going to tell me that I have 450. 3 times 50 is 150. So that I wind up with 600. Okay? Now remember I said that by writing this, this results in a point. Okay? So I want you to think about what this point means. These are candles, and this is cost. Okay? So what does this mean in the context? If whatever, for some reason it costs $450 to set up our candle making equipment. Again, this is just made up arbitrary stuff, so I'm not looking to debate how much it does candles. I have no idea. I don't. I think we found this someplace. So this means if I want to make 50 candles, that it's going to cost me $600. Okay? So that's really all it comes down to. And then I'll do this. I'm going to view. I'm going to split our screen up. So I'll split the screen so it makes it a little smaller, but it'll still work. All right, so then problem number 2 says determine the output of the function when the input is 100. Okay? And interpret both in the context. Well, the input means, when you talk about the word input, means it's the next value. It means you're basically doing the same exact thing. You're doing C at 100, which is 450 plus 3 times 100. So that gives me 450 plus 300. And so that gives me 750. And again, remember, I said when you have it in this notation, this results in a point. So the above problem was if I make 50 candles, it's $600. This is if I make 100 candles, it's $750. So 100 candles is $750 to make. And again, I'm not a candle maker, so I don't know if this is an accurate price or not. I know when I go to the Target with my wife, they have all those candles, and she's like, "Well, I find you here." I'm like, "Yeah," and I'm just smelling all the candles because, I don't want to really shop. All right, number 3 says interpret both the y-intercept and the slope in the context of the problem. So this is our original problem. So I'm going to rewrite this. So it looks like y equals mx plus b. That way I can identify things a little easier. Okay? So what this means is, oops, that should have been 450, I'm sorry. This means 0, 450, which is the y-intercept, like your setup cost is $450. Before you even made your first candle, you've already invested $450. Whether that means it's buying the wax and the wicks and the scents and all those kind of things, and whatever the company preliminary needs to set up. And then this 3 here is our slope. So I'm going to take our slope and I'm going to make it a fraction. So this means that each candle is $3 per one candle. So it costs me $3 for each candle I make, however I make it. Okay? And then it said, determine the number of candles produced if the total cost of producing those candles was $1,950. Okay? So they told us that we have $1,950. So remember, our equation was this. Well, X in our equation represents candles. C at X is the cost. So I'm going to take this, and I'm going to replace that. I'm just going to make it 1950 equals 450 plus 3X. Subtract 450. Those cancel. So 0, 0, 5, 1, 3X. Divide each side by 3. So it looks like if you had a price, if you went and picked up your candles and it was $1,950 and this was the relationship they had done, you got yourself 500 candles. Okay? So determine the number of candles. We did. 500 candles. 500 candles cost us $1,950. I don't know if that's a good price. I hope it's not the little tiny birthday candles. I hope they're the big old ones. All right, and then number 5 says, hey, an employee says that 200 candles would cost $1,000. And they want to know, is this accurate or not? So what we can do is this is an X value. This is our C at X, which is our Y value. Okay? So I can do one of two things. I could set 1,000 into for C at X, or I could plug 200 in for the candles. They're both going to get you the same idea. So I'm going to take the 200 and plug it in. So C at 200 is equal to 450 plus 3 times 200. 200. So 450 plus 600. So that comes out to 1,050. So let's say your employee says, oh, you want 200 candles, and that's going to be $1,000. Did your employee underestimate what they should be charging, or did they overestimate? We'll take a look at this 1,000. If you are a company and your employee keeps shorting you $50 on an order, that employee might have a different line of work to look for. Agree? So this was an underestimate. The employee missed the price by $50. And again, yes, we could dispute that a company would say, hey, you order the 200 candles, you get a price break. I mean, there's all kinds of things you could sit there and say, but they didn't justify that in a short story. And then they want us to find C at 75. Well, C at 75, I'm going to take my equation. I'm going to go C at 75 is equal to 450 plus 3 times 75. I think 3 times 75 is that, let's see, 3 times 5 is 5. Carry the 2, 21, 225. So C at 75 is going to cost us $675. Good enough? Phones away, please. Phones away, please. Headphones off, head, please. All right. Problem number 7, friends, I think is a dumb question. So I'm going to skip it. I think it's silly. It's a silly question in my opinion. Okay, if you ever have done any rock climbing, you do not climb at a constant rate of speed. Okay, so I think it's a bad example. We're going to throw it away. We're not going to use it again. Got it? And then problem number 8, we want to find f at 25. Well, they give us the equation of f at x is equal to negative 3 over 5x plus 1. So all I'm going to do is just plug this in and solve it. Number 9 is the same idea. We want f at 20 or negative 20. So I'm going to plug negative 20 in for x and solve it. And then problem number 10 I'll actually do. Problem 10 says, hey, y is equal to negative 5. So you're going to take this negative 5 and you're going to plug it in for f at x. So you get negative 5 is equal to negative 3/5 x plus 1. We learned a skill a long time ago to say, hey, let's clear denominators. That way we don't have to deal with the fractions. Those cancel. That gives me negative 25 is equal to negative 3x plus 5. Subtract 5 from both sides. I get negative 30 equals negative 3x. Divide by negative 3. So x equals 10. Okay? And then for the problems below, I'm going to look at my slopes. I have one slope of 0.7. I have another slope of 2 over 3. I have another slope of negative 2. And I have another slope of negative 7 over 2. Okay, and they want you to figure out which one is the steepest slope. Put the slopes of linear function in order from least to greatest. So I want to go from steep to less. Okay, and the best way to do that is, let's convert everything into a decimal. That 0.7, 2/3, if I plug into a calculator, gives me 0.667, rounded to 3 decimals. Negative 2 doesn't convert any lower. And then negative 7 over 2 is 3.5. Okay? So what we want to do at this point is we want to find, it doesn't matter if we have a negative slope or a positive slope, there's still a steepness factor. Okay? So you look at your largest value, not worrying about our negative sign. So this is the most steep line. This is the number 1 steepness. Okay? If I would go down 3.5 and right 1. That's given us the steepest. Thank you, sir. Appreciate you coming in. I'll get that graded probably by the time you have class, okay? And then I'm going to go to my next one. So this one here is my next steepest line. And then this is my next steepest line. And then this is my 4th place winner. Okay? So we're talking about the steepness factor. I'm not worried about it being positive or negative. You're just looking for what the pitch of the line would be. Is it really steep growing, or is it really steep declining? And then they want us to calculate g at 9. So if we're finding g at 9, I'm going to look at the g at x equation. And we're going to find g at 9. So that's going to give me 18 over 3, which is plus 5. So that's 6 plus 5. So this gives me an answer of 11. So this, again, is going to yield me the point 9, comma 11 if they wanted us to plot it. And then the last question we have is calculate g, or f at 8, excuse me. So we're going to look at my equation that's f at x. And this is why we label the functional notation with different letters so we can identify different equations. So if I have this, I'm just going to plug, I'm going to say f at 8 is equal to 1.5 plus 0.7 times 8. So 1.5, 7 times 8 is 56, 0.7 times 8 is 5.6. And then we're going to add those up. So 6 and 5 is 11, put a decimal, carry the 1, 6, 7, 7.1 is f at 8. Not a good one to plot if we wanted to put a dot on a graph, because 7.1 is kind of above 7, but when we have a little tiny graph, it's kind of goofy. So my friends, that's how that homework works. Seem okay? Questions for me? All right, let's go with this. Go back to view. Nope, oh, I didn't want to go tiny. View. I'm going off. All right, I'm going to go back to the beginning of my notes. I am on page 165 in the book. Let's see, 165. So I think that's 165. So we've already worked a little bit with point slope, okay? But we're going to talk about it a little bit more. We're given this. Now, item 1 is 3 comma 4 the y-intercept. No, it doesn't have a 0 in which spot? X. Good. So 3, 4 is just a point. So I'm going to go over 3 and up 4. I'm going to put a dot. Okay? So then they tell us, hey, we have a slope of 2. So I'm going to take 2 and I'm going to make it 2 over 1. That way it gives me a vertical and a horizontal component. So from here I'm going to go up 2 and right 1. Graph my line. We need to graph the point and the slope. We did that. We can use the same information to write the equation. Okay, so the equation of the line, we're going to use this equation. And again, I'm going to give you these equations. I'll have them written up for you. This is called point slope. Okay? So I'm going to label this x1 and y1. So all I need now is I'm going to plug in a y1, an x1, and a slope. Well, I have a slope of 2, an x, and a y. Or x1 and y1. So when you plug them in, they become opposite values. So your positive 4 becomes minus 4. Your slope is 2. Your x, your positive 3 turns to a negative 3. And here's our equation. Okay? Point slope is actually the most used, but it's actually the one that I want you to start feeling comfortable with. Because if I say, hey, give me the equation, give me the linear equation, point slope is a lot less work to put into. If I said, hey, solve this for y equals mx plus b, you would have to distribute the 2, then you'd have to add the 4. Or you could be done here if I just asked for, hey, what's the linear equation? Linear equation, here's your point slope, it's done. You don't have any further to go. Okay, does that make sense? And I know we've dealt with point slope a couple of times. We've graphed with it. Now we're going to go backwards and using it. So the nice thing is, this is the equation, point slope, and they call it point slope form. I don't know why they call it form versus formula. I wasn't at the math meeting when they made that choice, 500 years ago. Okay, so there's really not too much to look at other than I will make sure I have that up for you. Okay. Then it goes to this one. It says, write the equation with a line, slope of negative 3 that passes through the point negative 1, 7. So this is my m value. This is my x1. This is my y1. So we're going to plug them directly in. My positive 7 becomes minus 7. My slope is negative 3. My negative 1 becomes positive 1 because it becomes opposite values. You're all done. That's all it takes. Okay, I'm not asking you to distribute 3 over the parentheses. I'm not asking you to add 7 to both sides. Okay, call it done there. Okay, next problem says write the equation with the slope of 2/5. So that's my m value. This is my x1. This is my y1. We plug them directly in. My negative 8 becomes positive 8. My slope of 2/5 stays there. My x value of 10 becomes minus 10. And you're all done. You don't have to go any further. It's just plugging into the appropriate locations, understanding when you plug in your x and your y values, they become opposite sign. Your slope stays the same sign. Okay? Problem number 3, we have a slope of this. We have a point of this. We're going to plug it into our equation. So I get y. My y value is negative 7. It's now going to become a plus 7. It changed signs. My slope stays the same. X, my 3 as an x value becomes minus 3. The equation's done. Okay? So if they just say, hey, write the equation, you can stop with point slope once you plug your things in. Okay? Now, if they ask you to write your equation in a certain form, then you have to look out for it. But I'll have listed up on the board, I'll have, hey, slope equation, point slope, slope intercept, standard form, all of those things. Okay? So number 4 on the last slide says write the equation line with a slope of 1/2. Okay? Goes through this point, so that's x1, y1. So we could do that. We were just doing that. My y value is -3. It's now going to become a +3. My slope is 1/2. My x value was a +4. It's going to become a -4. Pass it through the point, and then change it to slope-intercept form. So this is slope-intercept form. So now I want to get rid of the parentheses, and I want to get y by itself. So I'm going to distribute 1/2 over the parentheses. And then I want to subtract 3 from both sides. Combine like terms. If it has an x, it's not a like term. So this is the slope-intercept form. Okay? This is the point-slope form. Okay, so if they say, hey, write us just an equation, but the reason we had to go one step further is it said, we want slope-intercept form. Okay? Some items that you'll need for today. Let's just do this plus. Okay, so for today, problems 1 through 3, you're just going to have to use the slope equation. And then you're going to have for 4 and 5, point slope from the graph, so you can totally do that. You can find the slope by counting. And then 6 through 8, you're going to use point slope. And it's also the same thing for 9 through 11. Given the following equation, the line's point slope form. And then the one thing that you have to realize is like number 11, when they have it listed like this is this point. If they have f at 3 on number 11, that would give this point. Okay, so that's some information. And then 12 through 14 on the homework, you're going to use point slope first. Get that crack. Get that crack. Oh, I wanted the back crack. And then we want to make it into slope-intercept, which is y equals mx plus b. So your assignment for tonight, and you can start on it now, is page 167 and page 168. And these are the clues of how to do it. Seem good, friends? Hey, what time are we out here?
11? Yeah, it's Tuesday, right? No, Thursday. I'm checking. Can you confirm 7:30?
7. Which one are you looking at? Number 1? You just need to find the slope is all. So just leave it at 7/3.